Hello everyone. Last time I made a video how to make a PCB over the FDM 3D printer, but it wasn't particularly good video. I thought I gonna just re-record it and keep the pure recipe without much of the try and errors. What I gonna do? First I gonna get the PCB layout from the Keycard. I gonna export it as the SVG format, scalable vector graphics. Then I'm gonna convert it into the pixel format. So JPEG, PNG or BMP, whichever it is. And I'm gonna use this as the texture to create the 3D geometry in the Blender with the displacement modifier, and then I'm gonna export this 3D geometry as the STL file. And this will be obviously used in the slicer for the 3D printer software. So that's the plan. And I'm gonna show you also the entire process of 3D printing it and etching. So this is the Keycard file. It is based on Atmega 328p and some other components, footprints, traces, etc. There are no zone fields because it will be more complex to print and work with. Yeah, so basically we need to export it as the SVG. I export it in the color because black and white is boogie later in the Inkscape. So yeah, color, board area only, one file per layer, and export. And export it. File, open, and Buck Cooper, for example. So choose this thing and export PNG image. Yeah, so those things look around right. The size is important, right? This 1100 pixels will give us plenty of resolution, right? And export. Let's take a look at it. Yeah, this is it. And the same with the front one. Export PNG, change the name. Enter. So here are those two files exported as the SVG, as the pixel formats. So welcome into Blender. What I'm gonna do here, I'm gonna use the displace modifier to make the 3D geometry out of this texture that I exported earlier. And then I'm gonna also use some Boolean modifier to make it more consistent as the 3D geometry. And I also add here some positioning places for this board. So yeah, this is what we start with. We can just simply tab into the edit mode, choose one of the faces, delete it, entire verticals. So we are left with just one face. And let's get into the modifier settings and add the displace modifier. Create new texture and get into the textures tab. And let's open one of those textures. It doesn't work because there's no geometry in here, so let's tab back into the edit mode and let's subdivide this face, W subdivide or WS. Now I have 16,000 verticals, 66,000 verticals, and one more subdivide for 263,000 verticals. When you would do one more subdivide or more, the work with this would be horrible and just so time consuming. So yeah. Okay, so this is what we got. But as you can see, there is this frame surrounding the texture. You can see this in here. This is the yellow frame here. There's the same on the top. So this is the one of the issue, and the other issue is that those traces are of different heights. That's because this texture has different colors here, right? White, yellow, green. So let's get into the paint. Actually, I'm using something called paint.net, but you can use the normal paint as well. I mean, it will be much more manual work, but the effect can be the same. So let's use the paint bucket to see this better. And another paint bucket here on those traces. I will just change the flood mode to global and paint all of those traces to white. So the last thing to change is the frame all around, and I just draw the lines above it. So this is the free app, and it's pretty old one, maybe 20 years or so. So it's nice and tested. Let's save this as back monochromatic. And let's get back to the Blender and let's reopen this texture. So now it looks much better. I reminded myself that those traces in here are too narrow. I actually I actually made a version of those traces which are wider. So I just open this another texture, and everything here happened exactly the same as to what I showed you, except I used the version with the bigger traces from the Keycard. So this is basically it, and now it should be scaled. So first I'm gonna measure the distance between this one and this one, because I know that each one of those are 5 millimeters, each one of those tubes here. This is the connection for the wires. So it's 5 millimeters pitch on those connectors. So on the entire should be 1 centimeter, 2, 3, 4, 5.5. So let's grab calculator. So 55 millimeters divided by 1,728.29. It gives this number. So basically let's scale it by this number. Scale the y-axis, right? Let's scale y. 0.03181. Yeah, that's the one. And let's scale x to have it some similar proportion. And the strength of the modifier 0.02, let's say. Okay, so let's measure it. If you press Ctrl, the measuring tool will stick to the geometry. So it is 5.5. Right. So now the second direction. Okay, so let's get back into Keycard, and we're gonna get the dimension that is perpendicular to the one that just was scaled. So let's measure distance from, let's say, here to here, only in the x direction. So it is 47.7 millimeters. Actually, it is 49.4 millimeters. So here in the x direction between let's press 7 to get the top view. So 49.4, if we divide it by 74.4, that's the value we should scale the x direction here. So this is 0.664, scale x 0.664, and let's check it. .493, and here is 493. Okay, so let's do the same with the other one. Shift D for duplicate, Z to move it along the Z axis. And now in the texture tab, let's make it unique. And let's open here the front texture. And in the modifier tab, let's change the texture of the displacement modifier of this new object into this new texture. So as you can see, there are two different sides of this board here, on the top and on the bottom. Okay, next thing is, because the slicer software for the 3D printer requires only the closed shells, and this is basically the shell, but the bottom is open. So let's do it through the Boolean modifier. Add mesh, new cube. Let's scale it for the similar sizes to those objects in there. Okay, so this will be base for one of them, and shift duplicates that, and this will be for the other one. And if you add modifier boolean, yeah, first it's good to save it. As the boolean modifier likes to crash. So let's do the intersect with the bottom one on the bottom one and analogical stuff on the top one. So those would be the shells used for the slicer software, but there should also be here some positioning pins. So I'm gonna add mesh cylinders, because basically you don't want to position on the same places where the traces, right? Where are the footprints. Because if you would position on the places where the footprints, then while drilling in the middle of the printing through those holes will just destroy those footprints. So it's good to make a separate positioning hole. So here is enough space for one of them. And shift duplicate in some other spot. Okay, so the only thing left is to make them in the same constraints of Z as are the previous geometries. Let's switch off those Boolean modifiers. And let's duplicate those two. Place them in the same spot. And on one of them we're gonna use the Boolean modifier intersect with the top one. And on the other one, the Boolean modifier intersect with the bottom one. And let's apply those modifiers. And let's switch on those modifiers that were turned off before. There are two checks that should be performed also here on this geometry. First one is to check the face orientation. If the face orientation is in one color, then it should be fine. And the second one, if the scaling was right. So let's choose both of them and let's put the top view and set wireframe. So it should be good. So let's export this STL. Selection only, scale 1000 because that's how Blender scales to the slicer. And this is one side. And this will be the other side. Here are the filaments that I have printed. That's the PETG, PLA, FlexiFill, and Moldlay. PETG hasn't printed at all. The adhesion was too poor to the bed, and it just couldn't stick to the bed. PLA printed on the board, but as soon as the PLA cooled down, it just broke off from the board in one huge piece. And FlexiFill printed pretty nicely. The entire one side, then I could even drill holes for the positioning, and then I printed the other side, and it was working up until the etching. In around 1 minute of etching, it just breaks off from the board, and it's failure also. It also has to be printed with bed on very high temperature, around 100 degrees. So when it cools down, it also can contract and influence breaking off from the board. I am not sure actually if it was breaking off from the board due to the cooling or due to the etching. Not sure about this one. But I tried it many times, and I have done really a lot of tries with it. So I don't think it will work as the final solution. And finally, I used the Moldlay. This is the filament for lost wax method of metal casting. So what's important here, it has very low contraction because the models cannot contract while after the printing, while cooling down. And because it has very low contraction, it also has very low tendency to break from the board. And you can actually use wax, even like normal candle wax, to make traces over the board. And they will stick on this board. So this is basically the reason why I chose it. Also, the printing temperature is very low on the bed, around 40-50 degrees. So it doesn't have such a long way to cool down, like for example FlexiFill had. And yeah, all the subsequent slicer settings will be just for this filament. Okay, so let me walk you through the slicer settings. So this is 0.3mm nozzle. It is pretty small, but the traces are small, so The limits doesn't apply as in the print settings. There is no adaptive slicing, so the layer height is just constant 0.24. And the retractions just work. This is the Z offset is for compensating the height of the PCB, and this will be different for both sides. So you can compensate with this, but honestly speaking, you will still run into some positioning problems on the second side. Doesn't matter how much you compensate here, you still have to manually level the bed again. So this would be in the printer settings. Okay, so let's get into the filament settings. There is the high extrusion multiplier. Remember that the print is just with the 0.3mm nozzle, so there isn't really much of the filament being pushed through this nozzle, and the extruder has only 200 steps per revolution in normal printer, so it isn't really that much. And if you still see some kind of dripping from the filament from the hot end instead of continuous lines being printed, then increase the print speed. It will also help. This is kind of an issue with such a small nozzles. What else? Extruder 220, bed 50, printing temperature, cooling. I actually take one from the ABS. This filament was printing pretty easy, so the problem is really with the extruder, dripping all the time instead of printing continuously. Okay, so the print settings. Layer height 0.24, and it's constant. I have this one switched off because this will ask the extruder to move around some of the traces, and with such a strange shapes, it will just book around and try to do some strange things with the extruder, like moving all around the entire board for no reason. So infill 100%, no brim, skirt however you want, and no support material obviously. Speed around 17. And acceleration 600. You can run it slightly lower. Okay, so what is left to do is grab the scissors for the metal sheet. Use them to cut the board to the size you really want. Then print like you are normally printing over the printer bed. Scrap off whatever filament you have on the bed. Place the board in this position. Secure it with the electrical insulation tape. At least that's what works for me for the base sheet bed. Then print over the first side of the board. Take the board out, drill through the positioning holes. Then print the other side on the bed of the printer. Mark positioning holes while scraping the filament off. Place the board, secure it with the tape, and print the other side. And at the end you just etch it. I usually etch it over the printer bed. I just crank up the temperature to around 70 degrees. So here are the few boards I have made using this method. This one is for a small potentiometer and the terminal. This one is the first one I made. This is the version with the smaller traces. So you can see some of them are missing here. Here is the version with bigger traces. I unfortunately have left the skirt in here. Wasn't too careful doing this one. But overall traces are there, so it will be useful. So thanks for watching, hopefully it was useful, and hit that like button.